All right, so this is number 2 from the second part of your review, okay? And so it's kind of like an application version of the remainder theorem, okay? So what we've got here, part A says, wants us to determine what k is within the polynomial if I've been provided with the fact that when I long divide x minus 3 into the polynomial, the remainder is going to be -10, okay? And so I'm just going to do a couple things here. I'm just going to rewrite the function. Function's going to be, just so I've got it, x to the power of 4 plus k x cubed minus 3x and then minus 5. Okay, and so that's the first part. The second part here is like we're making the claim, or they're stating that when I evaluate f of x at 3, the remainder, or the y value, is going to be -10. Okay, so this is essentially like f of x. And so what I'm going to do is replace x with 3, and then the value of the function f of x is -10. So I'm going to go -10 is going to equal, and everywhere I see an x, I'm going to put a 3. 3 to the power of 4 plus k times 3 cubed, and then minus 3 times 3, then minus 5. Okay, so I'm just going to do the math now. You'll notice the only thing I don't know is that k value. So I'm just going to solve for it. This is part A. Okay, part A is to solve for the k value. So -10 is equal to 81. 3 to the power of 4 is 81, plus 27k, that's 3 cubed, right? Minus 9 and minus 5. So if I do the subtractions, okay, we're going to get -10 take away 81 plus 9 plus 5 is going to equal to 27k. And you're going to see that we get -77 is equal to 27k. Divide both sides by 27. And there's your k value, as ugly as it is. Okay, so now I could rewrite this polynomial. Okay, f of x is going to equal x to the power of 4 minus 77 over 27 x cubed, I believe, yeah, minus 3x minus 5. Yeah, okay. So the second part is determine the remainder. So part B now. Part B now wants us to find the remainder when I long divide, or I keep saying long divide, divide x plus 3 in. So we're going to divide that into this polynomial and find remainder. Okay, so we're going to use remainder theorem to do that. Okay, and it's going to work out nicely. So if I were to actually then, I'm going to evaluate the function at, remember, it's got to be the opposite of that, right? So this is written in factored form, so the thing that the actual factor itself is going to be -3 if it were actually a factor. And so I'm just going to evaluate the function at -3, right? Minus 77 over 27, -3 cubed, minus 3 times -3 minus 5. Oops, okay? And so you're going to get 81 minus 77 over 27 multiplied by -27 plus 9 and then minus 5. So you'll notice here the 27's drop out and the two negatives are going to turn into a positive. So we're going to get 81 plus 77 plus 9 minus 5. Okay, and so we should see that we end up getting a remainder of, when we use remainder theorem at -3, we're going to see that we get a remainder of 162. Okay, that's it for number 2. The part C there was just asking you to graphically verify your answer. What you could do is you could actually put this function into Desmos, right? So I guess part C could be Desmos, and check that f at -3, like check the actual point on the graph. Okay, so that's part C, and that's it.